Hello everyone. We'll continue the second part of the cyber physical system. So we have done some of the applications in the previous video. Now today we will see applications of CPS in the smart grids. These are some of the applications of the smart grids, that is the smart meters, demand management with distributed generation. You have automated distribution with intelligent substations, wide area control of smart grids. Then you have PMUs, DAUs. These all are the application areas of CPS in the smart grids. Coming to the smart meters, these are the digital devices that measure energy usage in the real time and communicate that data to the utilities. Unlike the traditional meters, they offer two-way communications, which allows the utilities to remotely monitor the consumption, then detect the issues and optimize the energy distribution. Example of these are automated billing, dynamic pricing, energy usage tracking. Now, here in energy, that is in automated billing, the smart meters automatically send the consumption data to the utilities for accurate automated billing without the need for manual readings. Okay. Then the second is demand management with distributed generation. Here, this involves optimizing electricity usage across the system, and especially with the integration of the distributed generation sources like solar panels or wind turbines. And this allows for better load balancing and resource allocation, ensuring that the grid operates efficiently. Okay. Examples are smart thermostats, renewable energy integrations. These smart thermostats, these are the devices which automatically adjust the heating or cooling in homes based on grid demands or pricing signals. The next is application area is automated distribution with intelligent substations. These are the heart of the modern smart grids, and these substations are equipped with sensor communication systems and automated controls to monitor, control, and optimize the distribution of electricity across the grid. Okay, here the examples are fault isolation, grid reconfiguration, and remote monitoring. This fault detection and isolation is like these can detect the faults uh, and quickly isolate the affected areas to minimize the disruptions. Then next is a wide area control of smart grids. Here it refers to the use of advanced CPS technologies in order to monitor and control the entire grid over a large geographical area. And this will allows the utilities to balance supply and demand, coordinate power flows, and enhance the grid stability, and especially in times of high demand or instability. Okay, so examples are the grid restoration. Then you have dynamic load balancing. So dynamic load balancing, here the system can distribute the power based on real time consumption and demand across regions, ensuring that no part of the grid is uh, overburdened. Okay. Then next is phasor measurement units, that is the PMUs. Here these are the devices which are used in the smart grids in order to provide real time monitoring of the electrical quantities like voltage, then current, phase angles, and the frequencies, and they play a vital role in ensuring the grid stability and detecting the potential issues before they uh, like uh, escalate. Okay, and here the examples are grid oscillation detection, voltage and frequency control. So voltage and frequency control, these PMUs, these will help in the real time voltage regulation, and frequency control essentially for integrating the renewable energy sources and maintaining the system stability. Then last one is the data aggregation units, that is the DAUs. These collect the process and aggregate the data from multiple sources within the smart grids. Okay, and here these DAUs, these are this centralize this data in order to provide utilities with actionable insights. And examples are the energy forecasting. Okay, and predictive maintenance. So here energy demand forecasting is these DAUs use historical and real-time data in order to predict the energy demand and helping utilities and adjusting generation and distribution plans accordingly. So these are the applications of the smart grids. Then you have applications of CPS in the industry. So these are the application area of the CPS in the industry. First is the manufacturing and the logistic integrated or integration with communication sensors and the actuators. So here this is manufacturing systems and logistic networks in modern industry are increasingly embedded with CPS technologies, and these include sensors for data collection and actuators for controlling and communication systems for real-time integrations and real-time interactions. Okay, and these systems enable seamless integration and between physical components like machines and belts and the computational systems, okay, that manage the processes and the decision making. Here the examples are smart warehouses and automated production lines. Then second is the smart control. So smart control, it refers to the ability of the CPS systems to monitor, control and optimize the industrial processes in real time. And here these systems, these use the feedback loops and advanced algorithms in order to adjust the operation of the machines and processes for efficiency, quality and the safety. And here the examples are automated assembly, then real-time energy management. So in real-time energy management, these smart control systems, these can optimize energy usage in industrial plants by automatically adjusting the lighting, heating and cooling in response to production needs. Then you have optimal resource utilization. Here this involves the effective management of both human and the machine resources, and these will ensure that all the components are used efficiently in order to minimize the e-waste, minimize the waste and maximize the output. Here examples are the smart factories. Then you have waste reduction. In smart factories, the manufacturing plants use the CPS to track the usage of materials and workers and machines and ensures that the production schedules are optimized for minimum downtime and maximum output. Okay, and next is the smart diagnostics and maintenance. Here this will leverage the CPS technologies to continuously monitor the health of the machines and the equipments and identify the issues before they cause failure and recommend or trigger the maintenance cost or the maintenance actions. And here the applications are conditioning monitoring, sorry, example are conditioning monitoring, automated maintenance scheduling. So automated maintenance scheduling is nothing but a manufacturing plant uses the CPS to continuously monitor the equipment, and when a sensor detects a potential issue, for example motor is running hot, then the system schedules a maintenance check before the equipment fails. Okay, that is about the smart diagnostic and the maintenance. Then you have flexibility in the system development. So here it refers to the ability of the CPS to adapt to changing industrial needs, and this flexibility allows the manufacturers to easily modify the systems and workflows in order to accommodate new products, processes or changes in the production requirements. And example here are the modular systems, then flexible manufacturing systems. Flexible manufacturing systems in an automotive plant, it can easily switch between the production of different vehicle modes using the same assembly line with CPS controlling the necessary adjustments. Then you have end product customization. So here, this is one of the most important benefits of the CPS in the industries. That is the ability to customize the products based on the customer needs. Okay, and here the flexible manufacturing systems and the real-time data analytics. These CPS can produce highly personalized goods at a scale, that is at a larger scale, by using this end product customization. Example is the mass customization. Then you have electronics, apparel. Okay, so here mass customization is this CPS will enable the production of the customized products on a mass scale, that is on a large scale, where the individual consumer preferences can be incorporated into into the production process without disrupting the efficiency. Okay, that is suppose any customer, he wants to add some uh, specifications in the car, that is his demand, then that can be added. Okay, that is nothing but end product customization. Okay, then after this you have the CPS architecture for 4.0. This we'll see in the next video.